Hello everyone, I'm Tan and these are my group members for Building Information Modeling and Data Management. Today we are going to present to you about the ICT use and ERD in geotechnical engineering. So let's start with the usage of ICT in geotechnical engineering. First, ICT is used to standardize engineering geological input data so that it allows the data has a better links with software packages and through data networks. The standardized data can be used in digital analysis of SCPT data. Due to the non-existing layers, it causes core penetrating test or CPT is not able to recognize all the layers correctly. Therefore, engineer can only identify the different layers by manual drawing. However, by interpreting the data through digital filtering techniques, the boundary between the layers can be identified accurately. Next, used in the collecting geological data. Geological data are noted down in manual field books, and the unstandardized and missing data in field books map paper is difficult to reconstruct the exact observation point. However, by using relational database management system and GPS, it can automatically receive the field coordinates and store the information in digital field book. And lastly, borehole logs data is designed to be connected to the software. All the information are stored in the database, and engineers are able to use the data for measurements of settlement during the planning of maintenance work in the future. And that's all for my part. Thank you.
Next, I will share about how the spectral model related to the engineering geological environment. 3D digital ground model is one of the spectral model can be widely used and facilitated in the geological field. Basically, 3D digital ground model is introduced all information on the spectral model and on the geotechnical characteristic of the ground layer below and around civil engineering work, such as tunnels and deep excavations for foundations. Next, it is the functions of 3D digital ground model. First, it allows us to input the true or simulated data interactively so that we can try a different types of scenario and we can come out a perfect solutions. Not only that, it can easily export layer configurations and their geotechnical parameters into a geomechanical model. Therefore, we can have a clearer image and details on how the subsoil look like. 3D DGM works very simple as we only need to key in recorded data ideally in the digital data system. Then the 3D digital ground model will automatically create a 3D layer model of the site area. Picture beside is the model shows that there is a large variation in the subsurface of a site in Amsterdam. That's all from me. Thank you.
Thank you. Now I'm going to present on the databases for large engineering geological data sets. Database that plays a very important role in collecting, storing, and organizing data. So our group has found two practical examples of large databases developed in the Netherlands. The first one is DINO, which is also known as Data Information on the Netherlands Underground. And they are being created to provide uniform access to data and information. The main aspect of DINO is first, enter the data into the database. Second, perform a quality control process to the newly entered data. Third, the DINO data that can be exported to do analysis and interpretation. And lastly, the results of the analysis can be re-entered again in DINO. The second example is database for an engineering geological mapping program. And the main purpose of developing this database is to facilitate the input and process of engineering geological rock and soil data. Second, it's a core data source for monitoring the temporal and spatial variation of rock and soil properties. And lastly, they also play as a very important source of information for all kinds of research topics. And that's all from me. Thank you.
Another usage of ICT in geotechnical field is geotechnical modeling. There are two methods of geotechnical modeling which are numerical and statistical. The first example for the numerical is Jian, which stands for Displacement Analyzer. This software provides constitutive model for tackling soil and rock material to analyze slope stability and construction. It can also analyze pore pressure, consolidation, groundwater flow, earthquake and liquefaction problem. The picture below here shows the example of Diana being used to analyze settlement and bearing capacity of a strip footing. Another software is Placis. It is used to analyze deformation of soil and rock. It can also be used for modeling of the 3D stress strain condition around a tunnel boring machine. The picture below shows the example of using Placis to calculate deformations of embankment. Next is about slope stability probability classification. It consists of three-step approach. First is using the scheme to classify rock mass parameter in one or more exposures. Next, allowance is made for weathering and excavation disturbance. Lastly, is about the assessment of stability of the existing or new slope in the reference rock mass. Thank you.
Okay, so the next ICT application that we're going to look into is the geological data exchange. Nowadays, the client community is no longer the professionals, but everyone is a potential users to all the geological data. Therefore, the data exchange need involvement of ICT to synchronize the data from heterogeneous information resources. We are going to look into the software involved in geological works. So what is GeoStar? It is a geological software that is commonly used by the industries in Poland. So what it do is it enables to creation of documentation cards for various geological works. So for example, borehole profiles. From the figure, we can see the scheme is showing the transferring of borehole data from GeoStar structures into the centralized CGDB structures. So moving on to the next is the EGDB, which is also known as Engineering Geological Database. It is a standard creation process and it contributes to the data visualization in one unified web browser window. It maintains the compatibility with the structures of central database. So last but not least, we're going to look into the ERD that we have designed to involve ICT in geological engineering. This ERD that is designed is to assist the customer in investigating on the site situation. In our ERD, we have 9 entities with attributes to describe the entity as clear as possible to the users. We design one-to-many, one-to-one, and many-to-one relation in our ERD to ensure that it works well in assisting our clients and also the authority involved. We're going to analyze the site situation basically based on soil sampling and also the rock sampling. We split our test on soil sampling into the undisturbed and disturbed sample tests. And for the rock sampling, we apply the rock quality designation to determine the rock type and also the rock quality at the site. Eventually, we record all the results into SI report to give a complete visualization and a comprehensive analysis to our clients. So that's all from us. Thank you.